Man, you better get every single part of this one right, man. Look how easy this problem is. We're going to rock this entire thing 100%, right? There's all my work. There's all my answers. We got a couple graphs up there. Part A, find the area of R. That's this guy right here. That's W. That's W. That's R. You're going to find the area of that. That's just, hey, no calculator. No calculator on this problem. There, you integrate 1 over X. You get the ln of X. Top minus bottom. We know the ln of 1 is 0. Boom. You got the ln of 5 to get the exact answer right away. Now, part B, they say cross-section perpendicular to the x-axis. So you think you might have to go through that whole cross-section part where you draw your S, find the length of S, and then integrate the area of your cross-section shape. But remember, when you do cross-section volume, you always integrate the area of your cross-section shape. They didn't give us squares or equilateral triangles or semicircles or anything like that. They just flat out told us what the area was. So you don't have to worry about doing any of that on your own. You know you're supposed to integrate the area of your cross-section shape. Since they gave us the area, that's what you're going to do. You're going to integrate that. All right. And this is our BC test. We can expect integration by parts to be on our BC test there. We know how to do this. You got a normal thing times a weirder thing. That's integration by parts. And then you're talking about R still. So you're still talking about, well, actually, you're just using that guy right there in between the 1 and the 5. And then you can actually use your shortcut because I can take that derivative down to 0 if that's my U. And I can integrate that. Now, remember, each time you integrate, when you integrate e to the power, you get e to the power. But each time you integrate it, your u is at power. So that's 1/5 times x. So when you do the derivative of that, that's 1/5. Your du is 1/5. Balance out with the reciprocal. You're going to times it by a 5 each time. So do the same thing on here, times it by another 5. And then we'll do our little shortcut. We'll do that times that, put that right there. That times that, put that right there. Please make sure you practice this on your own without the use of the calculator. Definite integral, top curve, top number minus the bottom number there. Use that fundamental theorem of calculus. So plug in the top number and then minus, plug in the bottom number. Just be careful with that. A couple of things cancel out right there. Combine like terms. Boom, 20 e to the 1/5 there. Okay. Easy problem, easy problem. Letter C, already at the last part of this one. Now it says find the volume of the solid generated when the unbounded means you're going to go all the way to infinity on this sucker. The region W is revolved about the x-axis. They kept this easy x-axis there. It's just our easy disk method right there. We're going to find the volume. You know, volume, got our disk method down. So it says your equation is already in terms of x's. You're going to revolve this thing about the x-axis right there. You want your rectangle drawn that way. You don't want to draw it sideways anyways right there. You want to go just from a curve to a straight edge. That's a dx problem. So your capital R is a distance from your axis of revolution up to your farther edge of your curve. So you measure from the x-axis up, that's equal to y, but this is a dx problem. So use your 1 over x squared. And your little r is a distance from your axis of revolution to your closer edge, which is 1 the same, which is equal to 0. So now since it's unbounded, remember you got your pi guy out in front, you got your capital R squared minus your little r squared. So there's the inside of your integral. And then you could even see from the graph, you're going to go from 3 all the way to infinity. And that's okay. We can expect stuff like that because we're doing this BC test there. We know improper integrals is a thing on the thing there. So remove the infinity, replace it with a b, do the limit as the b approaches infinity. They're going to want to see that notation in there, that limit as b approaches infinity notation. And then you have an easy integral. Ignore the limit notation for a while. Easy integral, that's x to the -4. So you integrate that, get x to the -3 over -3, get rid of the negative exponent. Make sure you get rid of the negative exponent before you start plugging in those b's and start doing those limits because it makes a difference where that infinity is at. And then we come over here, plug in the top number minus the bottom number, and then make sure you have your limit notation right there. And I would just kind of you don't even have to write that part down. Like, so you need that limit notation of this thing. And then when you have 1 over infinity, you just know that's going to go to 0. And then what you're left with is this 1 over like 3 to the 3rd times 3 to the 1st. So that's 1 over 3 to the 4th, which is going to be 81. So you could actually leave it as pi over 3 to the 4th. You'll get full credit for that, or pi over 81. Boom, you got your volume answer right there. Garden hose with the nozzle. Oh, hold on. Got a nozzle right there, man. Industrial, no, I guess not industrial strength, but I'm an expert gardener, man. What, 125 PSI, gonna be blowing flowers out of the ground with the 125 PSI.